Hello students, welcome to EduWave online classes. Today is our third video on the chapter of work, power and energy. The first two have already been uploaded in YouTube. The links for those two will be provided in the description box, and today we will be learning the third part of this chapter, that is energy. So let's start. So what is energy? Capacity of doing work is called energy. That means how much capable we are of doing some work is known as energy. Now, as already I have taught you that energy and work are the two sides of the same coin. The more energy you spend, more amount of work gets done, and the lesser amount of energy you spend, lesser amount of work is done. So now we come to the SI unit of energy. Now, since energy and work are almost equivalent to each other, therefore their SI unit and CGS unit both are same. So the SI unit for both work done and energy is joule, abbreviated as capital J, and the CGS unit of energy is erg. Now, as already you know the relation, again I am repeating once more that the relation between joule and erg is this one. 1 joule is equal to 10 to the power 7 erg. Okay. Now, there are some bigger units of energy as well, that is 1 kilojoule, that is 10 to the power 3 joule, 1 megajoule, that is 10 to the power 6 joule, and 1 gigajoule, that is 10 to the power 9 joule. Now, although joule is the SI unit of energy, there are some other conventional units of energy. So let's see what are those. And kilowatt hour. Now, what do we mean by these watt hour and kilowatt hour? Suppose I write 1 watt hour. What do we mean by this? If the power spent by the source is 1 watt, right? And this 1 watt power is spent in 1 hour, then we say that 1 watt hour is equal to 1 watt power is spent by the source in 1 hour. Then only we say that the energy is 1 watt hour. Similarly, for 1 kilowatt hour, we say that 1 kilowatt power is spent by the source in 1 hour. Now, this kilowatt hour, this unit of energy is used mainly in electrical energy, for electrical energy. So what is the relation between kilowatt hour and joule? Let's see. 1 kilowatt hour is equal to 1 kilowatt into 1 hour. We know that 1 kilowatt is equal to 1000 watt, and 1 hour is equal to 60 minutes, and 1 minute is equal to 60 seconds. So if we want to convert this hour into second, that is 60 into 60, that is 3600 second. And we know that 1 watt power means 1 joule of work is done in 1 second. So this watt can be written as joule per second. So from here, second and second cancels. And if we write this in exponential form, after 36, 1, 2, 3, 4, 5, that means 10 to the power 5 joule. Now, if we convert this into standard form, then we get 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. This is the relation between kilowatt hour and the SI unit of energy. How did we get this? We have divided this 36 by 10. Therefore, we have got 3.6. And since we have divided all of a sudden by 10, we have multiplied with 10 as well. So 10 to the power 5 into 10, that gives us 10 to the power 6. Now this kilowatt hour is also known as the commercial unit of electrical energy. Commercial or Board of Trade unit. Board of Trade unit of electrical energy. In short, we write it as BOT. I hope this much is clear, the relation between kilowatt hour and the SI unit of energy. Now, we will be learning one common unit of energy that is mainly used in case of heat energy. So let's see that. Now, the common unit for heat energy is calorie. So what do we mean by 1 calorie heat? Amount of heat required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. This is known as 1 calorie heat. We take 1 gram of water whose initial temperature is 14.5 degrees Celsius. We want to raise this temperature to 15.5 degrees Celsius, that is by 1 degree. We want to increase the temperature. So whatever amount of heat we have to supply to 1 gram of water in order to change its temperature by 1 degree Celsius is known as 1 calorie heat. And 1 kilocalorie heat is almost the similar thing. The entire definition will remain the same. The minor change that is done is, instead of taking 1 gram of water, we will take 1 kg of water. So the amount of heat required to raise the temperature of 1 kg of water from 14.5 to 15.5 degrees Celsius is called 1 kilocalorie. And 1 kilocalorie, in short we write as KCAL, is equal to 1000 calorie. Now what is the relation between calorie and joule? Let's see. 1 calorie is equal to 4.186 joule. Or some of the times, in order to simplify our task while solving numericals, we round it off and we write 1 calorie is equal to 4.2 joule. Now, this is the common unit for heat energy, kilocalorie or calorie. Now, for subatomic particles, energy lost or gained is expressed in electron volt. Now let's see what is electron volt. So when an electron is accelerated through a potential difference, I'm writing in short PD, potential difference, when an electron is accelerated through a potential difference of 1 volt, the energy gained by the electron I am writing in short as E negative, the energy gained by the electron is called 1 electron volt, right? Now all these terms, potential difference, what is volt, whose SI unit is volt, the detailed analysis of these terminologies we will learn when we learn the chapter of current electricity. So when an electron is accelerated through a potential difference of 1 volt, the energy gained by the electron, because whenever anything accelerates, that means a force is applied, and whenever force is applied, work is done, and whenever work is done, the body gains energy. So the energy gained by the electron under such condition is called 1 electron volt. Now, what is the relation between electron volt and joule? 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. So all these relation between kilowatt hour joule, then calorie joule, electron volt versus joule, all these relations we are expected to remember from the examination point of view, because anytime they can give us such a question where we need to do these interconversions. Okay. Now, these were the things that we have learned. Now, one more question that they can ask, that is the difference between energy and power. Now, since energy and work are equivalent, so whatever difference I have taught you between work and power, the same differences are applicable for energy and power, with only slight difference, that is the definition of work is different from the definition of energy. This much is enough. Rest of the point of differences will remain same. Now we come to conservation, or rather before doing conservation of energy, let us learn a few more things. That is, we know that mechanical energy of any body is the sum of potential energy plus kinetic energy. Total mechanical energy of a body is the sum of its potential energy plus kinetic energy. Now what is potential energy? Potential energy is the energy possessed by a body by virtue of its rest. That means when a body is static, it is not moving, it is not dynamic. The energy possessed by a body due to its state of rest or configuration is known as potential energy. And there are two types of potential energy. One is gravitational potential energy, and another one is elastic potential energy. Now already gravitational potential energy formula I have taught you, that is given by mgh, and the formula for elastic potential energy is half kx square. But even if you do not remember this half kx square, that will also do, because this is a part of class 11. But what you need to memorize is the definition of potential energy and the two different forms of potential energy. Okay. Now, kinetic energy, and generally for potential energy, we are interested with this one. Till class 10, we are interested with this one. Now, kinetic energy is the energy possessed by a body by virtue of its motion. That means when a body is moving, or either in a linear way or in a circular path or rotational motion, that means when a body is in motion, the energy possessed by the body is called kinetic energy, and the mathematical formula for kinetic energy is half mv square, where half is the constant, m is the mass of the body, and v is the velocity or the speed with which the body is moving. Okay. So the expression for kinetic energy is half mv square. Now one question that we are being asked some of the times, what is the relation between kinetic energy and linear momentum? So I am writing kinetic energy as K. Instead of writing Ke, I am denoting by K. Now linear momentum is denoted by P, and linear momentum is the product of mass and velocity of a body. And linear momentum is also a vector quantity, because this velocity is also a vector quantity. Scalar multiplied by vector results in a vector quantity. So from here, what is the value of V? So V can be written as P upon M, right? So we will replace this value of V in this equation for kinetic energy. So therefore, kinetic energy is equal to half M. In place of V, we will replace P by M. So that is P by M whole square. So kinetic energy will be half M into P square upon M square. So 1m from the numerator cancels 1m from the denominator. So kinetic energy is equal to P square by 2m. This is the relation between kinetic energy and linear momentum. Now this can be further simplified in different forms, like if we take P square and cross multiply K with 2m, we get something like this. P square is equal to 2mk. Now if we take the square root on both the sides, the square root and square cancels on the LHS, and on the RHS we get root 2mk. This is the standard form in which the relation between linear momentum and kinetic energy is denoted. P is equal to under root 2mk, that P is the linear momentum. Now the SI unit of linear momentum, this is for some additional information, is kg meter per second. Either you can write it like this or kg meter second to the power -1. Both are correct. This is for additional information, and this is from the examination point of view. You might be asked a numerical based on this concept between relation between linear momentum and kinetic energy. So here we end today's class. Keep yourself updated with our channel. Stay tuned, and in our next video we will be coming shortly with conservation of energy. Till then, keep on studying. Bye bye.